Well, yes. Hello, everybody. I'm Roberto, and well, this is the presentation I've been working on for you people. So please enjoy. Reset and start. So, what have you? So, Roberto, what have you been working on lately? Ever received this question? I have a particular relationship with it because answering it takes time. Even answering to people with a software background. This presentation is an attempt for me to answer this question to the entire office. So, yeah. The okay, okay. Too long didn't watch. I am working on smart contracts for the Ethereum blockchain. This is the short answer. This is the correct one, but it's also generates a lot of new questions. What is a smart contract? What is Ethereum? What is a blockchain? So I want to answer all of those questions first in order for people to understand. Okay. First of all, the the obligatory slide. What is a blockchain? A blockchain is, in short, the most basic thing is a fancy data structure. Each row has a hash that points to the previous row's data. If the data changes, the hash changes. If the hash changes, the chain is broken. I have here a small demo for you to understand it. Well, where's the demo? Oh, okay, Plan B. Let's go. Okay, let's. Okay, this is a small. The, Imagine this is text. If this text goes through a mathematical equation that produces this hash at the bottom. So if I add, this is the same concept that goes through for passwords, for example. You add up, you will get a password, you pass it through SHA-256, and it gets this code. But these hashes are actually pretty magical in nature. If, for example, I add to the data being queried, I add a single letter. Notice how the entire hash changes, almost every digit, just with a single letter. But if I start removing letters and I make exactly the same ones as before, the hash returns to being the same. That's the reason why, for example, you can store passwords. You can store hashed passwords on a database because the given an input and given the same input and in the same mathematical equation, you get the same result. But you cannot predict what the result will be before running it and having the inputs. It's what is called in cryptographically a one-way function. So now that we understand more or less how a hash works, let's do a block with it. So a block let's say a block is only three values that are being hashed together. The block number, this which is the nonce, which is a nonsense number. We'll see what it works for later, and any data I want. I- in a and let's say that I want my rule as that each hash that I they only accept blocks that have a certain number of zeros before it. So let's say this hash has, for example, four zeros preceded. But if I add a single letter, the entire hash changes. You see, it no longer has the rule I decided. So it changed to color to red, and it's now an invalid hash. But if I remove it, it's valid again. Now, how would I make if I wanted to commit data to this block and have it with a valid hash? I just add my data. Let's do something really large, and then I have to mine it, as in looking for a nonce number that when you have this number and this data produces a hash that starts with four zeros. Let's do it. Magic. It said that with this number inside the data structure with this data produces this hash, which complies with my rule for a valid block. Now that we have a valid block, we can see how they combine for a blockchain, for a chain of blocks. something I don't know called blockchain. So let's go with it. This is the third demo. Here you have three blocks: block number one, block number two, and block number three. Each one of them has, besides the block number, then the nonce number that is used to generate a hash, and the current hash. It also has the previous hash. So, for example, the Genesis block, the first block created, has a hash with only zeros. These four values are hashed together and create this hash, SHA-256. This hash is then added to the next block here, and then this entire block is also has to be mined with all the data in it, and it also generates a hash as this that also complies with the rule that it starts with 4 zeros. And this happens exactly the same way here on the third block. So what happens if I try to to forge this data, to change something here? Bam! Not one, but two invalid blocks. Why? Because my hash in block number two, my hash has changed, and now it does not comply with my rule that has four zeros in front of it. And also, this hash has also invalidated all the blocks in front of it. From this point forward, all blocks are invalid. So now I must validate this block again, and you can see that it's a completely different hash that was generated the last time, and it's already added here. So now I must also mine this block in order for it to be valid again. And when I mine it, the nonce changes as well. So yeah, for if you have to revalidate all data if you want the chain to continue. But how does this translate to multiple peers? This is now the distributed demo. Now we have here three peers. Each of these peers has exactly the same chain, exactly the same has exactly the same chain with exactly the same data and exactly the same length. So let's say peer B is malicious, peer B is evil, and has changed my data here. Bam. Now notice that the hash has changed, just like the previous like in the previous demonstration. So I have to mine it again to produce a nonce that is different from the nonce that existed in the previous blocks, and creates a completely different hash from the previous time. But also that but on surface level it complies with the 4 zeros. And now here I forge more data and I mine it, and now I have here a completely different hash from this one. But here's the kicker. Peer A and peer this is a distributed system. The systems vote on which is the correct block. If peer B tries to put this chain onto the network, it will be blocked because the other peers have different hashes and they are voting, hey, that hash is incorrect. I have this hash that was generated before and has a timestamp that is before you. So why will I accept your blocks if I know they are incorrect? So it's very easy to find a forgery here. So the main takeaways I want from that small demo is number one, hashes are not pointers. That is one of the main misunderstandings of this data structure. Let me see. Let me get this notes. That is one of the main misunderstandings of this data structure, since people tend to equate this to sys pointers. That is false. The hash is inextricably linked to the data. If the data changes, the signature changes, the hash changes. That breaks the entire list since that node. One node, if the node breaks, the entire list since that node breaks, not only that node. And you have noticed that a forged block is very easy to spot in the demo. And even if a peer insists in proposing a bad block, nobody will listen because the consensus mechanism requires that a majority of the peers agree to adding it. Worse, there is actually a financial incentive to find forgeries. Remember that miners get a reward when they are the first to confirm a block. If I can prove that my block is correct rather than yours, then I get a block reward and not you. So more money for me. We all, Now we all agree on this point and on these takeaways on these few points. Okay, good. Now here is the Now here comes the part where I blow your collective minds. What are the implications of this data structure? Number one, all the data is fully validated by all peers. If the blockchain is valid, then all the data it contains is valid. You can trust that all the data stored is 100% validated by all peers. Because if a single byte is changed at any point in history, the entire hash will change, and since that point, and the entire chain since that point will be marked as invalid. Each piece of data is as valid as the block where it resides. Number two, no single party can influence the consensus mechanism. No government, no individual. If anyone tries to slip a forged block, then everyone will notice. If anyone tries to coerce the chain into changing data, then everyone will notice. Just the same way where you cannot repeal the law of gravity just because you put it in the parliament. The number three, you can trust the math and not the people. As much as we love humans, all humans have incentives to lie and cheat. As we have had to trust the maintainers of a system that they are delivering us the truth. As an example, remember in any country, especially in ours, the COVID case count. There's always the lingering doubt in our minds that our government is fudging with the COVID case count and the infections in order for political gain or to make themselves look better. But But the data recorded in a blockchain cannot be coerced. It is true because there is mathematical proof that it's real. There is proof that it was added. There is proof that who added it. There is proof who changed it. And if it was deleted, there is proof of who deleted it. That's it's 2 plus 2 equals 4. Math. Simple math. And the final one, the cherry on top. There are thousands of replicas worldwide by default. This is a decentralized network, so the data by definition has to reside in thousands of places across the globe, and thousands of nodes, thousands of copies. Anyone can get a full copy of all the data in a blockchain and can run analytics on it or execute transactions or even propose new blocks. If a peer crashes or is knocked out by a government or criminals, then I can work off another peer. So the data is always fresh and equally valid in any place where it exists. Okay? Yes, here are the caveats, of course. Nothing is perfect. It is a piece of technology, and we have to understand that things that there are things that can be improved still. Number one, the proof of work is very expensive. This is the reason why Bitcoin consumes as much energy as a small country. The more power a proof of work network consumes, the more secure it is. But it also incentivizes an arms race between miners of who can consume more energy. And right now the popular networks are working very hard to address this, but it's a real issue and an environmental problem that proof of work is very expensive. Number two, finality takes time because this is a distributed network, so it can take your transaction to be added to a block up to 15 seconds. And even then, the network can decide to reorganize the blocks and instead accept your transaction in another block, or just because another peer validated a block before you. And so a transaction is not really done until after several minutes after it was made. The the third one is UX. You will notice that still the user experience is not what it's supposed to be and still very difficult to maintain, and it's very complicated for people to understand some of the backend and some of how everything works. The UX still needs a lot of work. There is also that security is proportional to the decentralization, and this one is insidious. The more peers and the more diverse they are, the more secure the network is. But the inverse is also true. If a network starts losing peers, then it will keep getting less and less secure, and that in turn will likely cause more peers to leave it, which will in turn cause it to be less secure, and that is a death spiral. Four, and that we will see that in a few slides, but nobody, since there is no central authority, no updates are voted on, they are not imposed. Nobody can impose network improvements, unlike Windows, for example, which can make Windows 11 and tell people that this is the new version of their software. Users can instead vote to stay in the current version or can instead upgrade to a competitor's software. Failed votes can cause the network to split and has already happened to both Bitcoin and Ethereum and will likely happen again. So let's begin first with the first part of the infrastructure, which is the networks. And here comes the big one, Bitcoin. It was invented in a white paper in 2008, and the first implementation was open sourced in 2009. The author is Satoshi Nakamoto. Nobody knows who he is. That's the simple answer. Nobody knows. He could be a person, he could not exist, he could be an organization, he could be the CIA. Nobody knows. There's a huge wallet with a huge amount of money to his name, but has not been moved since 2008. So nobody knows. It works via proof of work, so it consumes a lot of power. It consumes as much power as a small country. This is the inventor of the blockchain concept, and this blockchain is particular in that it only supports money transfer, as in account A transfer to account B, account C transfer to account B. All of those transfers are listed, added in the block, and then validated. That's mainly the main kind of transaction that Bitcoin supports, which is fine. That was what it was designed to do. Now, remember the thing that I told you about that upgrades cannot be imposed and have to be voted on? Well, Bitcoin has already suffered several hard forks in its lifetime. So these are different networks with different protocols and different coins that have different values of Bitcoin, but they all started as Bitcoin, and they all have part of the registry and the part of the ledger of Bitcoin, and then they shifted to their different implementations. First off is Litecoin, which changed because it has a this one's a little different, and I think it started from scratch because it has a different uses a different validation algorithm, which is faster and less power consuming, but it hasn't caught up as hard as Bitcoin itself. Then in 2017 there was some sort of civil war between Bitcoin Cash in Bitcoin, where some people wanted the network to stay stable and not have big changes, while there was another party that wanted to upgrade the network for increased throughput and increased number of transactions per minute because they were starting to get too expensive. So the people that decided to upgrade the network and do a better and do cheaper transactions and faster transactions, they split the network in two, and they became Bitcoin Cash, and they took with them a lot of the network's peer power. And then the Bitcoin Cash people suffered a second civil war, where a part of those peers also split off and became Bitcoin SV, which is another hard fork. So if you ever find yourself buying Bitcoin, make sure it's Bitcoin as in the Bitcoin network and not Bitcoin as SB, which is Satoshi's Vision, which is a different network. Uh, Disclaimer: I work on Ethereum all day, so I'm very biased towards Ethereum. So I'm going. With that said, let's start with this network. It was proposed in 2013 as well in a white paper, and the network came online in 2015. It also works with proof of work, but it's moving to proof of stake in 2022, which is a lot of power savings. It allows transactions, and it also allows smart contracts, and you can add data to the blocks. We are going to see that later, but smart contracts are a big deal. It also suffered a hard fork just after release, with the when there was a hack and the entire network voted to modify the existing code in order for that hack not to happen. But the old hack still existed, with a few peers that decided not to, that because of ideological reasons, decided not to not to join in the not to join in saving from the hack. So they became Ethereum Classic, as in another hard fork that it, for ideological reasons, it still exists and a small network there. These are other public networks that came after Ethereum and have different ideas and have different concepts of how transactions work and how smart contracts work. They are still fighting. They haven't caught up that big lately, but for example, we have EOS and Tron, which they market themselves as Ethereum 2. There's Cardano. I think it was founded by one of the co-founders of Ethereum. So there's some big names there, and there's Tezos, which Tezos had also an ICO, but and had problems launching, but now it's online, so it works. Hyperledger. I wanted to talk quickly about Hyperledger here in the networks. Which is essentially a private blockchain, permissioned, instead of the peers being public and anyone being able to join the network. Here you have to be validated by the network itself first. So you have to pass you have to ask for permission from the existing network peers. Also, you can customize the consensus and have your own private networks and such. So it's a particular use case for corporations and data that you don't precisely want public. For example, medic data that it's probably not a good idea to have it on a public blockchain. So now we come to the next part, which is what I told you was a big deal. These are the smart contracts. This concept actually predates blockchain. It was proposed proposed in a white paper by Nick Szabo in 1996. A smart contract, in summary, is a small piece of program that's stored in the blockchain itself, and it executes automatically. And it's executed by the network, not by the one who calls it, by the network. The transaction result is saved on the block, and it also includes some sort of database, some sort of persistent state. That persistent state, the reads are free because every node has all the data in it, but the writes cost money. The writes, you have to put a little crypto money for it to work, which is called the gas. I want you people to think of smart contracts as vending machines. You insert money and it gives you a chocolate bar. You can also see this is in this particular vending machine. You can see what kind of food there is. There you can see it has chocolate bars. You see it has sodas. You see it has water. If you want something from it, you can see how many. If you can see if there's still copies of it, and if there is, you can just put some money, press a button, and it gives you your chocolate bar or your soda. Put some money, press a button, something happens. That's the way that's just what's supposed to be spending machines, and that's how also smart contracts work. So this is a very small demo contract. There are only two methods here. You can use this to store a number. Anyone can use this to store a number and get that number. Once this is deployed to the network, anyone in the world can call the store value against any node, which will change the value stored in the blockchain. Then anyone else in the world can call the retrieve function, this one, and get the number that is currently stored. The value is stored in the blockchain itself, and the contract is executed and validated by the network. This is a big concept. Two people are storing data securely inside the blockchain without having met in a network that neither had to put up. And well, and also these smart contracts are surprisingly versatile, and people have already created many projects on this small building block, like NFTs, for example. NFT comes from non-fungible token. It's a contract. Uh, there's a typo there. Damn it. There's a contract that records ownership of a value in a contract. The value can either be an ID or a hash, but the validity depends on the legitimacy of the issuer of the contract. There are I put in this slide two completely different examples to see how they to see similar to see a similar way of that will work in the physical world. For example, has anyone here played Magic the Gathering? For example, uh, yes. Okay. How do you know a card is valid? If for example, if there are thousands of them, millions of them printed every day. Well, well, hmm Well, the way that the risk, the validity of the that's my fourth point there. The validity of the card depends on the legitimacy of the issuer. If the issuer is Wizards of the Coast, the company that prints the cards legitimately, then the card is legitimate. If it's not printed by Wizards of the Coast, then it is not legitimate, and anyone can make a copy. I can go to my printer and print a few copies of cards and play with them, and with the same rules. And if the people decide to use them, I can be to play against me with them. It's fine. But the real cards in tournaments have all to be validated by Wizards of the Coast themselves, even if there are multiple copies of them around the world. The other example is from the other side. Here is the national. It's in that's the here in Panama. That's the National Public Registry. It's essentially an office where you go to find who owns which corporation, who owns each piece of land, which is the SA. You just go there and pay them money and go back 24 hours later, and they return you with a piece of paper with a stamp that says this company, these are their directors, this is when it was registered and this company exists, and all of that, and all the legal information of that, and that's used for transactions and legal stuff with the government. But they also have a web page that you can use to find that data. You can essentially go to the web page of the public registry and print the same data that they charged you for. But why is that data that is printed from on your own computer not as valid as the data that was printed on the that has the stamp from the public registry? The reason is because the one who printed the stamp gives the public registry legitimacy. So and NFTs are a very interesting concept, and they are going to be, and they have a lot of uses. For example, in logistics and finding out how valid is one thing and how legitimate it is. But um, they've also been found. But the last years, some people have been using it for other different uses, which are particular. Uh, this one. Remember this news? Remember this? This is the first NFT auction from Christie's. It sold an NFT of a digital image. That NFT ended up worth $69 million. The reason why it's worth that is because Christie sold it, and because the artist itself accepted that as a legitimate copy. So the NFT has legitimacy. So people can. So yes, it's if it says it's worth it, it's worth it. This is a less commercial example, but yeah, I found this quite fun a few days ago. These are two Coinbase employees that created a smart contract with two NFT copies. When they exchanged rings, they took out their phones and sent the copy they had to each other. So the result of that transaction is now stored in the network forever. Yeah, that comes now with the next level on top of the smart contracts, which is a word that is gathering a lot of steam these few months, which is decentralized finance. Uh, for this, there are several platforms that I have to explain, and then the big picture will suddenly come together. Um, this is one of the platforms that I want to talk about. This is MakerDAO. They make a coin called DAI. It's essentially a central bank that is it's a central bank that is not operated by any human. It's a series of smart contracts that detect the price fluctuation between Ether and dollar. If Ether gets too costly, then they sell Ether in order to keep the value of the coin exactly the same as $1. So the value of the coin is pegged to the dollar because of a smart contract that sells and buys according to the value of the dollar at the moment. It works. That's more or less how central banks and the Federal Reserve work. Yes. This second platform, for example, is called Compound, and this is a deposit account and loans. This is essentially a decentralized bank. It also is a series of smart contracts that are operated by no human, but that you can deposit your DAI in this platform, and it will accrue. You can deposit there, and you can gain interest. And you can also take loans against the DAI that's in Compound, and you pay the interest for the loan. The interest that you pay for the loan is actually fed as the interest for everybody that has deposited money. That's essentially how banks work these days. The loan interest is the one that's feeding the interest for the deposit accounts. This is a third platform, which is a decentralized exchange, and it's a liquidity pool, and anyone can trade any two tokens again via smart contracts, via no person involved in this. Uh, Imagine the board game Catan. Let's say I want to buy two wood for three clay. I can just upload that order into the Uniswap, into the network, and if somebody accepts the order, my results will be returned to me. So I will get my two wood, and I will send back the clay. Everything without escrows, without intermediaries, only through this network. There are many platforms that work like this. In particular, tokens are the smart contracts that act as accounting ledgers. They record the ownership of an amount and record all transactions between those accounts. All of these tokens in particular work on the Ethereum network, and this is a small example. This is only a very small example of the tokens that are available already, and all of them have different uses. Some of them are store of value, like DAI, as I told you, or others are used as voting power for a protocol, which is Chainlink and Uniswap. They have their own tokens, but they are more voting power. A quick summary: Tether and USDC, they are a company that has a bank account. You deposit $1 and they return you one token. So you are sure that your token is valued at $1 because you go back to them, ask them for the dollar for your token, and they return you the US dollar. DAI, I already explained how it works. Uniswap, Chainlink, and Compound are used for voting for voting on upgrades on the protocol itself. BAT is earned via ads via Brave browser and used to buy ads on Brave browser. And there's Wrap BTC, which works similar to how USDC and Tether work, but instead of accepting dollars, they accept Bitcoin. You deposit Bitcoin them, and they return you one token that is worth one Bitcoin, that is supposed to be worth one Bitcoin. Because if you go back to them and present your token, they return you the Bitcoin. But the incredible part here, and this is what makes DeFi, decentralized finance, is that all of these protocols, all of them interact with each other. As an example here, I can use Uniswap to exchange BTC to DAI, and then use that DAI in a loan on Compound, and then use that loan to purchase a futures contract on an exchange, and then sell that contract to another exchange for a profit. That's called arbitrage. And with that profit, I immediately pay off the Compound loan and all the interest, and then I pocket a small profit. Everything, all of that is done in a single transaction, then validates in a few minutes. And this is the kind of financial wizardry that the people on Wall Street do every day. But this time without intermediaries, without escrows, without relying on stock exchanges or old banks. This is open for everybody to use. Finally, you need some way to interact with all of these protocols and all of this software. So this is you need a wallet. You essentially you need a wallet. Uh, this is one of the most popular wallet right now, and it's in a browser extension that works on Chrome and Firefox, and it also has a version that is available as a mobile app. This software, this extension or app, it stores your crypto private keys, and then you can use that extension to see websites. Those websites can ask the extension for you to sign transactions, and allows you to use your wallet and your funds through websites, as in you press a button on a website, it goes to the website, calls the extension. The extension sends you up a small pop-up that tells you this is a transaction, these are how many coins it will cost, how much it will cost, do you accept. You press accept, and the transaction is sent. This is for these are a few screenshots of that app of that app being used on. So, let's cycle back to my original statement. I'm working on smart contracts for the Ethereum blockchain. Does it make sense now? Thank you very much for everything. So I just wanted to do one final slide before we do the QA. The plan that we have for this is today was my plan for today is that this was a deep dive, a big picture on this huge background of platforms that are being built on right now. The next session, we will work on this. We will write a small smart contract and then upload it to Ethereum Net, to the Ethereum testnet network. And on the third session, we are going to make our own crypto, our own token that can be used on top of the Ethereum network. So yeah, thank you for everything, and that has been my presentation.